to this final exam worksheet. I'm going to assume that you know how to solve an equation because we've been solving equations throughout. So the thing we want to look at here are these inequalities because the inequalities are things that we don't look at all the time. We had them in chapter 3, and then we haven't really looked at them since then. We had them on the exam, the midterm exam, but and you'll see them on the exam. But it's important to remember these. So let's refresh our memory about them. They work just like inequalities. I'm sorry, they work just like inequalities work just like equations, but we're going to have a range of things and not just one value equal to x. So the first thing we want to do is we want to put together anything that's alike. Those are alike over here. Those are alike there. So I'm going to do this in a kind of a 2 or 3 step process. So negative 8x and negative 5x is negative 13x. And then there's a plus 4. And then we got 8 plus 8, so that's 16 minus 15x. So now we've got one that we're going to just collect like terms across the equal sign, which means just like with an equation, we're going to do the opposite. So if we plus 15x and plus 15x, and then we're going to minus 4. So this is going to be 2x. So these are going to be gone, and those are going to be on, and then you got less than 12. Does that look right?
Yeah.
All right. So now we're going to go ahead and divide everything by 2. So x is less than 6. They're not labeled, so we can just make either one. All right, let's see. If you go to the, let's see. See, the thing is, I don't really have a password on it. I don't know why. Let's see, where else can I get one? I think I can get it out here. Let's see. I know there's a way to get it. It's the same thing for everything. Okay, there we go. Can you give that to her?
KX3 E.7.
You gotta kind of copy and paste it because it's got a period and it's got that funny sign in it. See, it's got S at, and that's capital S, and the at, capital K, little x, 3, capital E, period 7. All right, so we can make either one of these 6. So let's make that the 6. And then this is going to be a parentheses. And the little arms are going in the direction of the arrow. So that's the graph. And then we can make it interval notation by just doing this. There we go. Any questions on that?
No.
All right. All right, now this one we need to do what? We can't really jump in and do what we did here because of that little part. So that means we got to do what?
X plus 36. 20x.
All right, so now we just got to collect across the sign. So that means, let's see, plus 20x. These few in here are the only ones where there's like a little, um, there's not enough space. So I need to squeeze things in here. So these are going, that's going, and I will have negative 4x is less than or equal to negative 32. All right, now here's where you got to watch out. When you got an inequality and you're solving for x and you have to introduce a negative multiplier, then what happens? It's going to turn this around. So x is greater than or equal to 8. Let's make 8 right there. It's greater than or equal to, so it's a bracket. So a little notation is just going to be as such. Remember, for both of your infinities, negative or positive infinity, that's always a parentheses because you can never get to infinity. This was for the less than 6, and this is for the greater than equal to 8. All right. What's the deal with this one right here? What do we have to do, generally speaking, on this one?
We have to isolate the x by dividing both sides by 2.
Yeah, and we're working in the middle, so that means all three, what you're saying on the other two sides, we're isolating in the middle, so we got to do the same to all three sides, or to the other two sides, what we do to the middle. So this is going to be real simple. 6 divided by 2 is 3. So 3 is less than, x is less than or equal to 6. And then we can just, and these are just going to, these are the easiest ones to write the interval notation for, and really the graph as well, because these right here are inherently saying and. So if we were to take these separately, in other words, 2x is less than or equal to 12, and 2x is greater than 6, put them together and see where they overlap. This is what we get by just sticking it in the middle like that. So here we go. Parentheses, bracket. Okay? All right, so now it's also a three-parter. But the first thing we got to do is we got to get rid of that 3, so it's subtracting a 3. So we're also going to do it over here and over here. So that means that we got negative 18 and negative 3z. All right. Now, again, we've got to turn this thing around when we divide by negative 3. Don't forget to do that. We're dividing everything by negative 3, so that's going to give us 6. And it turns it around. All right, so all of them are positive. But there's a little problem with that. It's kind of cattywampus. If you were able to like put your name like in letters that were write your name on the letters and then just put it like on pencil and spin it around or put it in the mirror. As you spun it around, it would be backwards. And if you wanted to get it right, you'd have to go around one more time. Well, that's kind of what we got to do here because the 2 is on the wrong side. The 2's got to be over here. But you got to keep these things pointing in the right direction. And then there we got it. All right. So again, so let's just say 2, 3, 4, 5, 6. So let's just say this is 2, 3, 4, 5, 6. And there we got it right there. So these are nice and easy because, like I said, you don't have to worry about the infinity thing. And if you were to put the 6 here, then it's obviously not right because the 6 is not to that side closer to 0. It's the 2 that's closer to 0. So you have to turn it around. All right, so let's just deal with them separately. Now this one's already done. All right. So this one, let me just put it down here. After this, there's plenty of room. And then this is going to be divided by 2 both sides. All right. So what we got to do is, let's just see, let's let this be 0. So this is negative 1, 1, 2, 3. So this is greater than 3, so it's going to be a parentheses, arrow in that direction. So that's the graph for it, but they also want the interval notation. It's a little bit hard to squeeze in here, but we should be able to do it. It's going to be parentheses on all ends, so it's negative infinity to the left. All right, so there we go. All right, so here's the graphing from chapter 3. I think is the way the word was. This right here was like 2.8 or 2.8, and then this was like 9.1 or something, the compounds. But that all went together with what was in chapter 3, which was the linear graphing. In other words, two-dimensional graphing, x and y. This has only got one dimension, only one variable. All right, so they want the x and the y intercept. The x intercept is when y is equal to 0, and then the y intercept is when x is equal to 0. So let's go ahead and calculate those two. Let's do y equal to 0. And if y is equal to 0, notice that that thing's going to go away, and we're just left with negative x is equal to negative 2, or x is equal to 2. All right, so that's the x-intercept. The y-intercept is just the opposite. It's when x is equal to 0. So that means this is going to be gone, and we're just left with 2y is equal to negative 2. All right, so there's the x and y intercept. Let's graph with that. Oops, I didn't want to do that. I want to make the other things big. One day we'll figure out why it does that. All right, so I'm going to put 2, 0, which is right here. And then 0, negative 1 is right there. All right, and let's put a line through it. So there's the line for it. Now, it's always good to have a third point. I'm not going to do it on these just because I want to kind of get through them a little bit quick. But down here, they ask for a third point. So we're going to do it down there just to give, so I can just give you a little bit of strategy on how to do it. The reason why down on here, these are more suited for that. And these are too. It's just that they didn't ask us to solve for y. But if you got in that y is equal to mx plus b format, if you got in that format, well, we already know what the y-intercept is, but we don't know what the slope is. But that's a better method to use for picking your third point than just picking something out of the blue. The reason why any point will work, but you could end up with a fraction, and if that rattles you, honestly, what I'm going to show you down there will be a little bit more interesting. So this is the same thing. So y is going to be equal to 0 to get the x-intercept. X is going to be equal to 0 to get the y-intercept. So let's just say y is equal to 0. And just remember here, when y is equal to 0, this is going to be gone here. In other words, you're just going to have 5x is equal to 30 left. You're eliminating that y term because when you put 0 in for y, negative 10 times 0 is just 0. All you got left is just 5x is equal to 30. All right, so there's the x-intercept. The y-intercept is going to be let x equals 0. So this is going to be gone, and I'm just going to have 10y negative is equal to 30. So there's our x-intercept. So 0, negative 3, 1, 2, 3. And then 6, 0, 1, 2, 3. 1, 2, 3. And there we go. There's your 2 points. And then we'll put a line through them. Now these both just happen to be very similar. They're not the same line, but they both got a very similar slope. They're leaning more this way. That's just a coincidence. So, all right. Any questions about those?
No.
No.
Okay. Now, this is a special case here. You remember what that special case is?
Isn't that undefined, I think?
Yeah, the slope is undefined because of the way it's laying. But let's just kind of look at this a minute.
Because anytime it's x is undefined, correct?
Yeah, anytime that it's just set equal to x. Why is voice coming in low? Let me see. All right, so x is equal to 6 would be 1, 2, 3, 4, 6. And if we just kind of keep going up here and keep going down here, all right, that's x equal to 6. Notice that x equal to 6 is right here on that x-axis, and x is always equal to 6, even when y is changing. And this is what we call an undefined slope. It's that vertical line is undefined slope. So let me write it on here using the little text box. So that's an undefined slope. Now, this next one is going to be the opposite. You remember how we had perpendicular lines? And like I said, this is kind of a special case because the undefined slope lays vertically and the y is equal to, or the horizontal line has slope of 0. All right. And this is slope 0. It's slope 0 because you can kind of think of it like this. That's horizontal to the floor. In other words, if you're laying that, you're laying at the same slope as the floor. Floor, when I say floor, not floor. So when somebody's horizontal, you know, they're laying down. There's no slope to their body. What we call a zero slope. All right, and again, I noticed there's a couple of people coming in. I got one from Donna. Thanks, Donna. But I put that formative evaluation up here. You can download it and you can fill it out. And you can use this PDF editor, that PDF to go. That was the one I was using earlier in the semester. And you can just put a text box in there and write in it and then save it. So if you do that, I appreciate it. I'll even stay with you afterwards or during the break if you need help. I need to turn these in tonight. All right, so slope. You remember how what the slope looks like? It's y2 minus y1
Over
x2
x1.
minus x1. If somebody out there else can talk, I don't know why you're low, Nicole. You're not you weren't low at the beginning, so I'm trying to figure out if it's me or I may need to plug in these headphones. They
I've
may
heard
be
of
dying.
go.
Uh, I'm afraid this is going to get worse. I don't know if that's what it is. Usually they stay charged for a long time. I'm not sure if that's what it is or not, but so, and this is given when you're given the 2 points. X1, Y1, and X2, Y2. It doesn't matter which one's got the 2's on it or the 1's on it, but you can't mix them up. They're both, the one's got to be 1, 1, and the other's got to be 2, 2. But you could do them backwards if you want to. You just can't cross them with strings. So, with this, X1, Y1, x2 y2. All right, so we got 8 minus 3 and 8 minus, so this is 8 plus 3 and 8 plus 5. So this is 11 over 13. That's the slope. All right, good on that? So it's just a matter of putting the things in there and calculating. All right. All right, so let's do this other one. This one's going to be a special case, as I remember.
I can hear you.
All right, so this will be x1. I like to label them because I have a habit of turning things around in my head. And then we just calculate. Throw everything in there. Now, just like with this one right here, the negative signs here are built into the formula. So if you have negative signs over here, you've got to take those into account. You can't ignore them. So that's -5 minus, that's built in, -4. And down here it's -4 minus a -4. Now what happens on this one? Again, this is an undefined restaurant. Look. Okay?
Yeah.
All right, so let's go on down here and do a couple more graphs, and these are ones where they ask us for a third point. All right. Now, the first thing they ask us to do is to put it in slope-intercept form. So what I'm going to do is I'm going to solve this one for y. In other words, I'm going to isolate the y's on one side, but I got to get rid of that one. And divide everything by -7. So this is going to be y is equal to, see, that's just going to be y. And then it's negative over negative, so it's 2/7 x. And then 14 positive divided by -7 is -2. All right. So here we got a free point right here, which is 0, -2. All right. Now remember, up at the top, I did the y-intercept and the x-intercept. Well, that's the y-intercept. So for the x-intercept, I'm going to just let y be equal to 0. See, so I've got 2x is equal to 14. All right, so let's put these in. Well, first of all, the slope was 2/7, and then the y-intercept is 0, -2. All right, now we need a third point. I'm going to show you what I'm going to do is. Okay, first of all, all right, 0, -2 would be right here. All right. Now let's find another point. Let's go up to 1, 2, and over 7. And you know what? That's just going to give us that right there. So let's just go down to 1, 2, and over 7. 1, 2, 3, 4, 5. So that's not supposed to be a point right there. Anyway, so just ignore that one. But you'll notice that these three, oops, I'm doing the wrong thing. I'm trying to grab the line. These are on the same line. So I found another point by going, let's see, it was 7, -7, and -4. Because when you start out from one point that you know where the line is, you can either go up, since it's positive, you can go up to and over 7, which would remind to this other one we already knew about. Or you can go down to, which brings us down to -4, and then over 7, which brings us to -7, -4. Because going in the negative direction twice, two negatives gives you a positive. All right. did we skip that one? I don't remember skipping that one. All right, so let's go ahead and solve this. So we're going to solve it for y, so we're going to subtract the 2x. All right. So then that means then this is the slope intercept form. This one will be a little bit easier. I should have done this one first. I don't know when I skipped it. I must not have been paying attention. So this slope is -2, and then the y-intercept is 0, 2. Once you solve it for y is equal to mx plus b like this, then the number hanging off the end is your slope. Your your y-intercept. That's your slope right there. So there's one. Let's go ahead and do y is equal to 0. When y is 0, then 2x is equal to 2. So there's that other point. And then we'll see if we can get the other one by doing rise over run. All right, so now let's try to find another point. Now let's put these on here. So 0 and 2 is right there. That's the 0, 2. X, no movement, 2 up. 1, 0 is right there. All right, now let's find us another point. All right, we got -2. So that means we can use either one of these to go. I'm going to use this one. So we're going to go down 2. So that's the slope here. So down 2, 1, 2, over 1. So that point right there is 1, 2, 3, -3. All right. And then, well, we did away with it. Then. Put it back. So it's down 2, 1, 2, and over 1. Let's put a line through it. I know we're spending a lot of time on the graphing, but the graphing is important because it's something we haven't looked at since midterm. So, because most of the other stuff, like I say, if you can do the graphing from before the beginning of midterm, and then basically you learn how to factor and you're able to put that into play, you can do everything else. All right. So any questions about the lines and all that?
No.
All right. So I'm hoping you remember these. I'm going to go through them briefly because we've been doing this from the time that we started in chapter 5. You just might not remember it, but let's go ahead. All right. These are all the same variables. You got both the quotient rule and the product rule. Product means when you multiply, you add the variables. So up here, x to the 2 plus 7. And this one doesn't have anything to do with it yet. X to the 9th divided by x to the power 3, and this is where we subtract. When we divide, we subtract. All right. Now this one uses the power rule. It's multiplying inside of parentheses by another power. So we got to raise everything in there to that power. If it's already got a power, we multiply it. So this is 2 times 4. The next one, the y, it has a power of 1, so it's just going to be down here. It's everything's going to get the cube. 2 gets the cubed, x gets the cubed, y gets the cubed. All right, so that's x to the 8th, y to the 4th. Nothing we can put together there. They're different variables. 2 to the 3rd is 8. And now we're going to match going up with the division. The 8's going to stay down there. And we got x to the 8 minus 3. And y to the 4 minus 3. So that's going to be what? 8, x to the 5th. And just a plain old y to the first power. All right, and in chapter 7, when we hit the last part of chapter, I'm sorry, not chapter 7, chapter 10, when we hit the last part of chapter 10 with the complex numbers, you treat I like it's a variable when you're adding and subtracting. It's just a matter of like terms. Well, it's the same thing here. What I like to do is offer the advice that if you're adding, you just drop the parentheses and you're going to collect like terms. So the things that are alike are these two. There's no match to this. Wait a second. Oh, I left it out. I'll just put it right here. It doesn't matter the order. And then these are alike, and then these are alike. So 2y to the fifth plus 2y to the fifth is equal to 4y to the fifth. Y to the fourth, this is also y to the fourth, it just didn't come out well. So it's a negative 9 and negative 6 y to the fourth. And then negative 2 plus 2 is 0, so this is all we got left on that. Now, the thing you have to realize about subtraction, just like I tried when we initially went over this, and what I tried to warn you about when you're dealing with the complex numbers, when you're subtracting, you've got to subtract everything that comes over here. In other words, we got to change the sign. It does not matter about the thing on the left. Those will stay just like this. Minus a minus 3x is a plus 3x squared. And then minus a minus 10 is a plus 10x. And then minus a positive 6 is just a minus 6. And then once you got that, again, you're back to where you're collecting like terms. These are alike. This is the only one like that. And then those. So put them in order. So 3x squared, just the only one like that. 20 plus 10 is plus 30. And what happens to the numbers, the constant terms? 6 and negative 6. What happens to those? Those are opposite. Same thing that happened up here. Plus 6 minus 6 is 0, so we don't have any more of those. All right, let's see. I was going to try to get down to here because that'll take us up to the chapter to test 4. This was all down here is test 5. So anyway, let's take a short break.
Okay.
And if you need help, if you want to do that thing, let me know, because I'd really like you to do it just so I can get... Okay, so what we've got here is factoring by grouping. And this is important because this can help us with the factoring of the certain quadratics. Remember the ones that what they call the AC method. Let's just kind of go over this a little bit. Remember, the first thing you want to do is break them in half, 2 on each side. The sign of the middle term or the sign of the third term is going to go on the right-hand side, so that's why I made it right there. So we look for the greatest common factor over this side, and it looks like it's just 2. And then it's y minus 9. And you bring that sign down. And then you're looking for greatest common factor over here. It looks like it's x. And it's y minus 9. All right. So here's our repeater. You only have to write that once. And then it's 2 plus x. You could write it as 2 as x plus 2 if you wanted to, either one. since it's a positive. All right. On this side, so there's my line. This is the sign that's going to come down. Look for the greatest common factor. There's an X in here, but there's also a 4. 4X is the greatest common factor. And then this is going to be 5X plus 6Y. All right. 4x times 5x is 20x squared. 4x times positive 6xy is 24xy. The sign comes down. Negative sign. Common factor of 15 and 18 is 3. And it looks like there is a y in both. So negative 3y into 15 gives 5 plus. With that extra x, take it along for the ride. And then negative 3y into negative 18 is plus 6y. Here's our repeating one. Four x minus 3y. Barely fit in there, but we got it. So any questions about that? That factoring by grouping is a lifesaver. Plus, you know, you're going to need it in a couple of problems. Again, this is one that once we learn it, we've not used it that much, but it does come in handy on a factoring like this, as we'll see in a minute. Now, in order to factor, you got to have these written in that descending order. X squared first, plus 3x, minus 28. All right, and then we need factors of 28 that have, since this is negative, we got to have factors of 28 that have a difference of 3.
7 and 4.
And that would be 4 and 7. Oops, 4 and 7. 4 times 7 is 28. And then this is going to be the negative one because the larger one is positive. All right. So 7 times negative 4 is negative 28. Plus 7 minus 4 is plus 3. So there we got it. All right, now this is one of those that you use the AC method, and then we got to factor by grouping, or at least that's the way I do it. There are plenty of other different ways. Usually they'll fall in the category of trial and error, which I just happen to hate. So 10 times 9 is equal to 90. Now, we need factors of 90 that add up to 21. And I do believe that's 15
and 6.
And 6. Thank you. 15 times 6 is 90. And they both got to be negative because that's the sign right there. They're both going to be the same sign because it's a positive, and then this tells us the sign. It really doesn't matter which one goes first. Sometimes, if you got a little bit of experience, you can figure out which one to put first. It might make it a little bit easier, but they'll all work either way. So, that's where we divide like at, and we take out the greatest common factor over here, which is 5y. And that's 2y minus 3, right? 5y times 2y is 10y squared. 5y times negative 3 is negative 15y. Bring down that sign. Look for the greatest common factor, which is just 3. And then that's going to be negative 3 into negative 6 goes 2y times negative 3 into positive 9 goes negative 3 times. There's your repeating one there. So there's our factors. Don't have to really think about it. Once you get these numbers, after doing the AC, A times C, it's really, the only thing that's really any guesswork is this part. And like I said, if you break it down into the fact, just look at that last number, they both have to be the same sign. This tells you what sign they have to be. They have to both be negative. And then you just take the greatest common, rewrite the middle term, breaking it apart into those two, and then factor by grouping. All right, this right here can be written as such. All right. So 8 squared is 64, x squared is x squared, and then 25 squared is 25. So we can write this as, because it's that difference of squares, 8x plus 5 and 8x minus 5. Okay?
Yeah.
All right, this one is asking us to solve by factoring. So what we got to do is we got to realize this is an equation, and then we got to subtract 40 from both sides to get rid of that. That's when we put it over here. Then this is going to be x squared minus 6x minus 40 is equal to 0. Okay, and then we're going to factor it. We got to find the factors of 40 that have a difference of 6. So it's going to be x minus and x plus something. Factors of 40 that have a difference of 6 are 10 and 4. And this one, because that number is negative, then larger one's going to go there. All right, so 10 and -4 are our solutions. All right, questions about that one?
No.
All right, now that next one is not a quadratic, so what we probably should do for all of our factoring is look for a greatest common factor. Because this one right here, there's a greatest common factor of x that's going to come out, and then we got 3, oops, I'm sorry, it's 3x. So it's x squared minus 9 and then this factors further, what's in parentheses, that's sort of like this one up here. Which one was it? Oh, this one. See, it's a perfect square on each end. So this is x minus 3, x plus 3. So that means we got 3 solutions. And if you want to know the truth, this tells you the number of solutions you're going to have, that power. So that's 3 solutions. And this just means that x is equal to 0. So x is equal to 3. All right, so there's the 3 solutions. That's a -3. All right. All right, so these are find the product and simplify, find the quotient, and then we got a couple of additions. So, for the most part, the way it works with multiplication, if you just factor them, you can strike out some of the common factors. And so my advice is always to start with the simplest one. And it looks to me like this is the simplest one because 5 only has two factors. It means 1 and 5. So they both have to be negative. So there's only one possible factor that this could have. It's x minus 1, x minus 5. All right. Now, negative 5. Now we can just use that one to divide into some of them to see if it's going to work. Well, 5 doesn't go into 16 or 72, but it does go into 20. So what does that tell us? This is x minus 5. And then this is x minus 4. Like I said, you don't have to go back to the start and look for your numbers that do this and that. You can use this as the hint. Negative 5 into positive 20 goes negative 4 times. Negative 4 plus negative 5 is negative 9. So that's factored correctly. Now, this is not the most well-constructed problem because most of these, when you factor them, you're going to usually lose almost all of them. With this one, it's a little bit different. Because I would be tempted to say negative 4 goes into 16 negative 4 times. But negative 4 and negative 4 is not 10, it's 8. So the only other possible is this is x minus 2 x minus 8. Now, 8 goes into 72 9 times negative. All right. So now we can just take out any that are alike. So x minus 8, x minus 8, x minus 5, x minus 5. And like I said, this one's a little bit different than some of the other ones because usually you would just have one pair left over, but this is going to give you 4 of them that are going to stay there. So that's all we can do. It would have been nice if there was one extra factor that came out, but they didn't see fit to do that. right, so next one is a quotient. So what we got to do is we got to take this one and turn it upside down. The other one stays the way it is. So to divide, we take the second number and change it. So that means up here, and down here is all right. Now, what would you start factoring first?
The z squared plus 6z.
Yeah, that's the easiest one. So let's pick on that one. All right. So what I'm going to do, I'm going to factor this one first. So this is just taking out the greatest common factor. So we're going to look for the 6 in one of these other ones. All right, 6 doesn't go into 72, but 6 will go, and it doesn't go into 27, so it's going to go into 18, and this is going to be nice and neat. because this is a z plus 3 plus 6. All right. So I used this one that was real easy to factor, and 6 only goes into one of these 3, and it was that one, and then that leaves z plus 3. All right, so now, remember, I'm working from this one because this one got turned upside down. All right, now, 3 goes into 27 how many times? These are all going to be positive. 3 goes into 27 7 times.
9.
I'm sorry, yeah, 9, yeah. I don't know where I was getting 7 at. I was looking at that 7, I guess. And then now 9 will go into 72 8 times. All right, so now let's just start striking all the like ones out. That's this one right here, all factored. So here, these are gone. X plus 6 and x plus 6. And then it's z, I'm sorry. I don't know why they have to switch back and forth like that, but they're all z's. So z plus 9s are gone. And so all that's left is z plus 8 over z. Okay. Yeah, this thing doesn't like to. Especially those z things. They're even harder to write it than x's. All right, now both of these are addition and their addition, and they both have the same denominator. So remember, when that happens, you're just putting them all over that one denominator and see if you can simplify it. And again, I'm going to use that x minus 2 that's down there as a hint, because negative 2 goes into 8 4 times. So up there, it's x minus 4, x minus 2, so it's just x minus 4. All right, now you got to watch out because this is subtraction. And if there was more than just a 15 there, and there's something like x minus 15, you have to pass the negative on to both of the things. But this one has just got that one number. So it's 3x minus 15. Same denominator, so we don't even need to write it once. And then we can factor. And then this factors as x minus 5, x minus 3. And these are gone. And we're left with just 3 over x minus 3. Now, one thing I'm noticing, they don't have one that's got a different denominator, but this right here will pretty much show you that process when you're dealing with an equation. And I'm going to do it the short way.
What answer did you
because,
get?
What's that?
What answer did you get for the last one? You scrolled up. I didn't see it.
3 over x minus 3.
Okay.
Does that look right?
Yeah.
3 times x minus 5. And then I use the negative 5 to divide it in 15, so I got minus 3. And minus 5 and negative 3 gives you negative 8.
That's what I got. Yeah.
So, all right. Now, if you want to go back to the worksheet and see the long way of doing these, be my guest. I hate the long way because the long way is just longer than it needs to be. It's true to what you're doing, but the reason why you're multiplying by the LCD is so that you lose all of your denominators. Here, now this factors as x plus 4 x plus 3 all right, so the LCD is just both of these here, so it's x plus 3 or x plus 4 plus times x plus 3. All right, now remember, when you're multiplying by the LCD, you're multiplying by the LCD over 1. All right? So therefore, if you're multiplying by both of these, then the x plus 4 and this x plus 4 are going to take each other out, and you're left with 1 times x plus 3, because the x plus 3 is going to stay in there. And when you multiply on this one times that LCD, the x plus 3's are gone, and you got 2 times x plus 4. Like I said, I prefer this kind of short way. But if you want to go back and see how they do it, you can see it in the book. You should probably is going to do it on those videos. But like I said, to me, writing it like that can be extremely confusing. And then over here on the other side of the equal sign, when I multiply this fraction times that over 1, then I'm going to lose the whole denominator, and all I've got left is a negative 1. Does that make sense? Okay. right, so that's just x plus 3 plus 2 times x, which is 2x. 2 times 4 is 8. Is equal to, so we're going to put together the x's. X and 2x is 3x. So this is going up here. And then the 3 and the 8 is 11. And so x is going to be equal to negative 4. Or so you might think. Tell me why x is not equal to negative 4. What happens if you put a negative 4 in that denominator? Negative 4 plus 4 is?
It cancels out.
It's going to be 0, right? So that would make this undefined. So this is no solution. So this is a proportion problem. Like I said, is the way these are set up, it makes it easy to solve, sort of like how I just did like this. It's just that with a proportion problem, you're multiplying the 7 times the whole thing and 5 times the whole thing. But essentially, you're doing what I'm doing there. You're multiplying by that missing factor. And I would recommend doing the My Math Lab exam homework, final exam review, because this thing right here, there's a couple of problems in here that they don't have that bothers me. And like I said, just because of time, I can't really put them in there. But what I would have done if it were me, one person making these, so you can't always root out your mistakes. But I would have put in a regular addition or subtraction of one that where they had different denominators. And the other thing I would have put in is write the equation of the line, and then the slope of the line and the slope of its perpendicular line. Remember that parallel lines all have the same slope. Perpendicular lines have the negative reciprocal. So this is 7x. to subtract 42. So these are gone, and these are gone, and you got 2x. So x is equal to -1. And these proportion problems, you don't have a problem with losing a solution, because you can see, especially on this, you can see there's no x down there. All right, any questions about those? We'll just do a couple more there.
Okay.
Teresa's out there asking me a question. All right, so these are proportion problems applications, and we're going to remember to get them in the form of two fractions equal to one another, and then we'll multiply across like that. The thing you got to remember is you cannot you got to line these up. In other words, what I mean by that. Okay, it says the ratio of a quarterback's completed passes to attempted passes is 4 to 9. So in other words, what we're looking at is like this: completed passes over attempted passes. And if you hold on a second, still not working too well with when I'm talking, I tend to go too fast. So this was the number of attempts, and that's the number of completions. All right, now what we got to do is we got to make sure we line them up over there. And this is something, if you ever paid attention to football, if you take 4 and divide it by 9, you get 0.44, so like 44%. So that's a 44% completion rating. But let's see, if we want to have that same ratio, and they say if the attempted passes is 45, so you got to make sure you put that in the right spot. You don't want to put it up here, because it says find out how many passes he would complete at that same ratio. Well, it's got to be an x up there, or a variable of some sort. And then you're going to go across. And that's equal to 180. All right. So that means
20.
x is equal to 20. And that's completed passes. And you can kind of see the same thing. Let's say if we take 20 divided by 45, see we get the same percentage. We get that 0.444. All right, so this one deals with like making lemonade and I assume this is sort of like you would make a lot of lemonade to sell it somewhere maybe. But it says that a can of lemonade calls for 2 scoops of mix. Let's put here mix over water. So we got to follow that same pattern all the way across. So 2 scoops of mix for every 22 cups of water. So that's a ratio. Now, what do they give us? They give us find out how much water. So we need an X down here now because the scoops of mix is going to go on the top, 40. And then we just multiply across. And then 40 times 22, what is that? That's 180.
180.
And then we're going to divide both by 2. So that means X is equal to 440. And that's cups water. So it's a lot of water. So they're going to make a lot of lemonade. All right. And it's water. All right. So everything else is pretty much just what we looked at in chapter 10 and 11. So hopefully that's fresh in your mind. I mean, we don't have another class. So if you want help, then you can take advantage of the tutoring. I saw that. Where's I know they got it over here. Under the dashboard on it's way back.
I actually think the final review homework is helpful.
What's that?
The homework that they have for final review, it's like the last bit that they have in my math lab.
It's what?
Uh, the last bit of homework in my math lab is the final review is what it says. It's like
Yeah, is the
three
date
some
messed up on
problems.
it or something?
Huh?
That's the last thing. Yeah. Is there something wrong
Yeah,
with the date?
yeah. I found that to be helpful so far because it kind of does touch on like two or three problems of everything.
Well, I can say this. That's the one that you should probably be doing since you're taking the test
Yeah.
in my math lab. I thought there was a. I know there's a thing here somewhere, and I just saw it the other day. Actually, I think it was yesterday. Anyway, it's in there somewhere. There's a link. Let me just check the dates in case there's an issue, because I'm still having trouble hearing you, and my AC just came on, so that made it a little bit worse.